Okay, let's unpack this. Today, we're diving deep into a really fascinating conversation with Noam Brown, who's a leading researcher over at OpenAI. He's known for some really groundbreaking work in AI and gaming, including building Cicero, and now he actually leads OpenAI's multi-agent team.
And what's so fascinating here, I think, is Noam's unique journey. I mean, from winning the World Diplomacy Championship just this year, 2025, to developing these really advanced AI systems.
Right.
It just offers these direct insights into the core challenges and, frankly, some surprising breakthroughs happening right now in AI.
Yeah, you might have heard him on TED Talks or maybe Lex Fridman. But our mission today really is to go beyond just the headlines. We're trying to extract the most important nuggets of knowledge from his recent insights, tailored just for you listening. Think of this as your shortcut, maybe, to understanding the real cutting edge of AI research.
Okay, so where do we start? His personal experience.
Let's kick off right there. His personal experience. He actually won the World Diplomacy Championship in 2025. I mean, that was just a couple of months ago.
Incredible.
And what's really incredible is that this came after he built Cicero, which was an AI already performing like in the top 10% of human diplomacy players.
Which kind of raises the question, doesn't it? How did his own gameplay, his human gameplay, how did that evolve after working so closely on Cicero?
Yeah.
Well, Noam describes how, debugging the bot actually forced him to really intensely focus to understand the game on a much deeper level.
Right, like a forced deep dive.
Exactly. He even played in tournaments, watched tutorial videos, and critically, seeing Cicero's kind of unconventional behaviors, that actually taught him new strategies, things he hadn't considered.
So the takeaway here is this subtle but actually really powerful example of human-machine collaboration. He didn't, use Cicero directly in his championship game, right?
Yeah.
But he definitely drew inspiration from its unique playstyle. It just shows how interacting with AI can really push human understanding forward.
And let's maybe connect this to the bigger picture, like the Turing test playing out in real time.
Right?
Noam shared some fascinating stories about early Cicero back in late 2022. Apparently, it would sometimes hallucinate just bizarre things.
Oh, quite.
Like telling a human player, no, your Windows, just completely out of context stuff.
Wow. Okay. And the humans didn't suspect it was a bot.
That's the crazy part. No, they just thought the human behind the keyboard was, tired or drunk or trolling. They weren't looking for a bot.
So they weren't even considering the possibility.
Precisely. They just weren't expecting one. Noam actually said he was really scared people would figure it out back then.
I bet.
But now, of course, Cicero has been announced, so people are looking for bots. But the twist is, current language models, things like GPT-4o, they've gotten so good, they're basically passing the Turing test consistently. It's much, much harder to spot them now.
That's a huge leap. And there's a key technical detail here too, right? Cicero was actually pretty small, relatively speaking.
Yeah, 2.7 billion parameters. And parameters are sort of like the knobs the AI can tune while learning.
Okay, so not tiny, but smaller than today's giants.
Right. And a key realization for their team was just how much AI performance benefits simply from having larger language models. Scale really, really matters. That was a big takeaway.
Interesting. Okay, let's shift gears a bit to AI safety.
Yeah, because what's fascinating here is how Cicero, despite being really persuasive, it was actually quite well received by the AI safety community.
Why was that? You'd think a persuasive AI might raise flags.
Well, Noam explained it was designed as a very controllable system. They specifically conditioned Cicero on certain concrete actions,
Okay.
which gave them a lot of steerability. It wasn't just a language model left to its own devices.
Got it. So it wasn't just, running loose. It had this clear reasoning system kind of guiding its interactions.
Exactly. And because of that control, many researchers actually reached out, seeing this as a, quote, potentially really good way to achieve safety with these systems.
That makes sense.
Yeah.
Which leads to the question, have they tried applying the newer O-series models like O3 to diplomacy? Has OpenAI done that?
So Noam hasn't done it directly, but he sees diplomacy as a great benchmark for these kinds of capabilities. He'd love to see the leading bots compete.
But they haven't yet.
His understanding, at least, is that the current models don't actually perform very well yet in diplomacy. So it indicates it's still, an active research frontier. There's something complex there they haven't cracked.
Okay, so moving on to these O-series models like O1 and O3. No mentioned the trajectory was clear early on.
Yeah, he said they saw consistent, rapid progress. What we're seeing now is a real broadening of what these models can do, and that includes much more sophisticated agentic behavior.
And for him personally, O3 has become really useful.
Hugely useful. He said it's effectively replacing Google search for his daily life, especially for what he calls meaningful research.
Meaningful research, like academic papers or...
More like a mini deep research assistant, something where you need synthesis and understanding, not just links. And he gets responses in like 3 minutes.
Wow, that's a big claim. And it kind of pushes back against a common perception, right?
Which perception is that?
Well, even among established AI researchers, there's this idea that these reasoning models, they only really succeed in domains that are easily verifiable.
Yeah.
Like math problems or coding tasks where there's a clear right or wrong answer.
Ah, right. And Noam challenges that directly. He points to his own use case, deep research, as a clear existence proof.
An existence proof.
Yeah, proof that these models can succeed in tasks that don't have easily verifiable rewards, where success is less well-defined, maybe even subjective.
Okay, so it's moving beyond just computation into something more like understanding or synthesis.
Exactly. And the shift is that people are genuinely surprised at the quality of the results in these fuzzy areas. They can tell the difference between a good report and a mediocre one, even if it's subjective, and that feedback loop helps the models improve.
That connects nicely to his analogy about System 1 and System 2 thinking.
Right, the thinking fast and slow idea applied to AI. System 1 being fast, intuitive pattern matching. System 2 is the slower, deliberate reasoning.
But he makes an underappreciated point about this, doesn't he?
He does. He highlights that the base pre-trained models, they need a certain level of that System 1 capability first before they can really benefit from adding System 2 reasoning on top.
So you can't just slap reasoning onto any model.
Pretty much.
Yeah.
He says if you try chain of thought, which is a System 2 technique, on a really small model like, say, GPT-2, it just didn't really do anything. You need a strong base model first.
He had a great analogy for this.
Yeah. If you ask a pigeon to think really hard about playing chess, it's not going to get that far. And he says this applies to visual reasoning, too. Like, System 2 helps a lot for complex tasks like GeoGuessr, where you have to piece clues together.
But not for basic recognition.
Less so. For simple image recognition, it's more like you either know it or you don't. The core understanding that System 1 has to be there before the deep thought really adds value.
So the model's foundational System 1 needs to grasp the basics, the rules, maybe even some metagame intuition, before its System 2 thinking can be truly effective and efficient.
Exactly. And this whole line of thinking leads him to a pretty bold claim about harnesses.
Right, the extra scaffolding or tools people build around models. What's his take?
He views them as a crutch. His philosophy is quite stark. The ideal harness is no harness.
Wow, so just improve the core model.
That's his belief. Models should fundamentally improve their core capabilities so they can excel at everything, rather than needing these complex external setups just to pass specific evaluations.
He gave an example, didn't he? Pokemon.
Yeah, apparently O3 doesn't do well at Pokemon without a specific harness, and his perspective isn't let's build a better harness, it's let's improve the base model so it can play Pokemon well.
Okay, but what about tools within the environment? Is that different? Like giving the model a calculator or a way to check rules.
He makes a distinction there. Giving a model a tool call, say, to check if a chess move is legal, that's fine in his view. That's part of interacting with the environment.
But what's not okay?
What's not okay is allowing the model to, say, make an illegal move and then just say, just kidding, and undo it.
Ah, okay.
He compares that to a robot breaking something in the physical world. You can't just undo that action. True test time compute, which is giving the AI more time and resources to think during execution, that involves simulating and planning before you act, not fixing mistakes after the fact.
That perspective on harnesses has some pretty big implications for developers building with AI today, doesn't it?
Absolutely. He talks about things like model routers.
What are those?
Systems that route requests between, say, a fast, cheaper, dumb model for simple tasks and a slower, more expensive, smart model for complex ones. Anthropic is explicitly doing this, for example.
So that seems useful now.
It is useful now, but no one believes many of these current efforts, including harnesses and routers, will eventually just be washed away by scale.
Meaning the base models will get so good they won't be needed.
Exactly. He cites how complex agentic systems that people built specifically for reasoning tasks. Well, they were largely replaced when the reasoning models themselves, like O1, emerged with that capability built in. The core capability just subsumed the need for the elaborate wrapper.
So OpenAI's ultimate goal is this single unified model, where you wouldn't need an external router because all the intelligence, fast or slow, is just in the model.
That seems to be the vision. And this leads to some pretty crucial advice for you, the developer listening.
Which is?
The field is moving incredibly fast. Things change fundamentally in like 3 to 6 months. So his advice is basically don't spend 6 months building something complex and then just have it be totally washed away by scale when the next generation model arrives.
That's slightly terrifying advice for anyone building products right now.
It is, but he did mention some exceptions to this washed away by scale rule.
Like what?
Oh.
Reinforcement fine-tuning.
Yeah.
RFT.
Exactly. RFT, where you take a pre-trained model and then train it further, using feedback specifically on your data to specialize it. He thinks that's pretty cool.
Why is that different?
Because it specializes the model on your specific proprietary data. And that data, that specialized knowledge, will likely remain valuable even as the general base models become more capable. So RFT sort of complements the model scaling rather than necessarily getting washed away by the scale. Your data provides lasting value.
That's a really important nuance. Okay, let's talk about the origins of this reasoning paradigm at OpenAI. There's a story involving Ilya.
Yeah, a really interesting one. Noam shared about a conversation he had with Ilya, OpenAI's co-founder and former chief scientist, back in late 2021.
Okay.
Noam was apparently pretty skeptical back then that just scaling up pre-training, just making models bigger on more data, would be enough to get to superintelligence.
Why was he skeptical?
He argued they'd likely hit economic limits first. You couldn't just keep throwing compute at pre-training forever. He felt they needed a reasoning paradigm as well.
And he had evidence from his own work.
Yes, from his work in games like poker and Hanabi. He knew that having the models think before acting, basically giving them time to reason, made a huge difference in performance, like orders of magnitude difference.
How big a difference?
He quantified it as equivalent to making the model 1,000 to 100,000 times bigger just through more efficient thinking rather than raw scale.
Wow. Okay, so what did Ilya think?
Ilya apparently agreed that reasoning was needed, but maybe felt it might not be that hard to achieve. And OpenAI had already been working on related ideas like reinforcement learning and reasoning techniques.
So the idea wasn't totally new.
No, but the early attempts were iterative. As the underlying models got faster and better, though, it became easier and quicker to run the experiments needed to develop the reasoning capabilities.
And when did the evidence for this reasoning paradigm become really clear?
Noam pinpoints it around maybe October or November 2023. That's when the signs of life became conclusive. And OpenAI, recognizing this shift, invested heavily.
Was everyone at OpenAI on board?
Apparently, there was significant internal debate. Some folks still believed pre-training scale was basically all that mattered.
But leadership saw the need for something else.
Yeah, leadership recognized the need for another paradigm, as Noam put it. The debate then shifted more towards, okay, how significant are these findings and how much should we really invest, especially back when compute resources were even more constrained than today?
Is there a story that kind of illustrates the impact this had?
There is. He mentioned a researcher who left OpenAI before o1, the first big reasoning model, was announced. And at the time, that researcher apparently didn't think the reasoning stuff was a huge deal.
Okay.
But then after o1 was announced, they saw how a major competing lab basically pivoted the whole research agenda almost overnight to focus on reasoning. And that made them realize the true impact of what OpenAI had developed.
So it seems obvious in retrospect, but it really wasn't at the time.
Not at all. And Noam suggests this highlights OpenAI's unique structure, kind of like a startup still, that allows them to make hard choices and place these big concentrated bets on potentially game-changing ideas, maybe more so than traditional academic or corporate research labs.
That's interesting. But even with all this progress on reasoning and algorithms, data is still a factor, right?
Absolutely. Noam points out that current models are still way less data efficient than humans. Think about how much data a baby absorbs compared to the vast amounts needed to train a large AI model to reach similar levels of competence in some areas.
So we learn more from less.
Essentially, yes. And he considers improving data efficiency one of the most important unsolved research questions. The answer might involve better algorithms or perhaps finding entirely new types of data to train on beyond just reading the internet.
Okay, let's make this really practical. For you, the listener, how do these advances actually show up in daily work? How does Noam use them?
He mentioned using tools like Windsurf and Codex constantly. Windsurf being an internal OpenAI tool, Codex being the basis for GitHub Copilot.
And his pro tip.
Basically, anything that I would normally try to code up, I try to do it with Codex first. Just make it the default starting point.
He also mentioned having AGI moments. What does that feel like?
Yeah, he said he's felt like he's interacting with AGI multiple times using these tools, but he compares it to seeing Sora videos, the AI video generator.
How so?
Initially, it feels like magic, just incredible. But then really quickly, you get used to it and you start noticing the flaws, the limitations.
How the magic wears off.
Right. But the good news, he says, is that progress is so rapid that you get these new AGI moments, these flashes of startling new capability every few months. The goalposts keep moving.
And the O3 model, the reasoning one, how does that fit into his workflow?
He said O3 has basically replaced Google search for me, which is a huge statement. Yeah. And he's surprised how many people don't even know that O3 exists or what it can do.
So his advice is to try it.
Strongly suggests trying these reasoning models. He thinks people would be surprised at what they can do, especially for that deeper research synthesis task we talked about.
But there's a trade-off, right, with O3?
Yes, the latency. O3 can take so long to reason sometimes that it can kind of break you out of your flow if you're coding or writing quickly. For those faster, self-contained tasks, Codex or similar tools are often better because they're quicker.
So even with these amazing tools, what's still broken in the development cycle? Where do they fall short?
He points to things like code review, specifically pull request review.
How so?
He describes the models, even the best ones, as being like geniuses, but it's their first day on the job. They have the raw intelligence, but they lack the context, the history, the experience of someone who's been working on that specific code base or project for months.
Right. They don't know the team's conventions or the unspoken context.
Exactly. And this creates what he calls an awkward state. Progress is happening so fast, but implementing seemingly obvious improvements, like better environment setup scripts or integrating project context, lags behind because it takes developer time and resources. It's a bottleneck.
Looking further ahead, where does he see AI impacting work beyond just software engineering?
He thinks it will encompass a lot of remote work kind of tasks, things you might find on freelancer platforms like Upwork.
So writing, analysis, maybe even project management.
Potentially. And this leads him to an intriguing thought about virtual assistants.
Oh, yeah.
He suggests that if models become aligned well, they could actually be really preferable to human assistants in some ways.
Preferable? How?
Because they could solve the principal-agent problem.
Okay, remind me what that is.
That's the classic challenge where you, the principal, delegate a task to someone else, the agent, and it's hard to ensure their incentives and actions perfectly align with your goals. There's always a potential mismatch. But in AI, if it could be truly perfectly aligned to your preferences, could theoretically do a way better job of acting purely in your interests than another human might.
But that hinges massively on that phrase, aligned well, which brings up the whole complex question of alignment itself, doesn't it?
Absolutely. Are we talking about safety alignment? And you don't build a novel virus.
Right.
Or just instruction following. Or aligning to broader humanity goals, or just my personal goals, even if they're selfish. That's a really deep, wide open question for the entire field.
Definitely something to ponder.
Right.
Okay, let's talk about his current role leading the multi-agent team at OpenAI.
Yeah, though he cautions the name multi-agent might be a bit of a misnomer.
Why is that?
Because a big part of their work is also scaling test time compute. Basically figuring out how to get models to think for hours, for days, even longer, to solve incredibly difficult problems that require deep, extended reasoning.
Okay, so it's not just about AI interacting with other AI.
Not solely, but on the actual multi-agent side where AIs do interact, he has this really fascinating take on human intelligence itself.
Go on.
He argues that the band of human intelligence is actually quite broad. He compares anatomically identical cavemen from tens of thousands of years ago to modern humans who, put people on the moon.
Same hardware, vastly different outcome.
Exactly. And what's the difference? He argues it's thousands of years of billions of humans cooperating and competing to build up knowledge, tools, institutions, basically civilization.
So intelligence isn't just individual, it's collective and cumulative.
That's the idea. And he sees current AIs as being like the cavemen of AI. They're individually capable, maybe, but they haven't had that long process of collective interaction.
So the goal for his team is?
The profound goal here is to eventually have AIs cooperate and compete with billions of AIs over a long period of time and build up a civilization of AI knowledge and capability, producing things far beyond what is possible today.
That's a huge vision. And he thinks their approach is different.
He says it's very different from historical multi-agent methods. They're taking a very principled approach that he believes the field has often been misguided on.
Yes, guided how?
Particularly, he thinks, by not following the bitter lesson.
Which is?
The lesson, famously articulated by Rich Sutton, that general methods that leverage computation and scale, like search and learning, ultimately win out over methods that rely heavily on human-designed knowledge or heuristics. He thinks multi-agent research hasn't embraced scaling enough.
Okay, that's a strong critique. Let's pivot slightly to his gaming background, poker and diplomacy. There are some really interesting strategic nuances there.
Absolutely. In poker, there's this core concept of game theory optimal play, or GTO.
Right, the unbeatable strategy.
Exactly. It's an unexploitable strategy that guarantees you won't lose money in the long run, in expectation. It's like always randomly choosing rock, paper, or scissors. Your opponent can't systematically beat you.
But that's not necessarily the most profitable way to play, is it?
Not always. Then there's exploitative poker, where you actively try to spot weaknesses in your specific opponent and adapt your strategy to take advantage of them.
Which can win you more money against weaker players.
Much more profitable, potentially. But the catch is, by deviating from GTO to exploit someone, you yourself become potentially exploitable if they figure out what you're doing.
So Noam's famous superhuman poker AIs like Libratus and Pluribus, were they GTO or exploitative?
They were fundamentally GTO. They were designed to be unexploitable. They beat the best humans, sure, but a skilled human could still probably make more money by exploiting a very weak player than the GTO bot would.
Why didn't they build an exploitative poker AI then?
He says making a truly effective exploitative poker AI is still largely an unanswered question. A big reason is the AI's lower sample efficiency. Humans can often get a read on a player, profile their tendencies in just a dozen hands or so. Back in the mid-2010s, his AIs needed something like 10,000 hands against an opponent to reliably identify exploitable patterns. They learn much slower from specific opponent interactions.
Okay, so that's poker. What about diplomacy? That seems different.
Very different, and this is where it gets really interesting. Noam found that in diplomacy, which is a 7-player game involving negotiation, alliances, and betrayal, that pure GTO strategy doesn't work well at all.
Why not?
Because of the crucial need for collaboration and adaptation, you can't just play a fixed optimal strategy when you need to persuade people, build trust, and react to shifting alliances.
You have to read the room.
Exactly. You have to understand the players and adapt to them much better. He uses the analogy. If you're at a table and everybody's speaking French, you don't want to just keep talking in English. You have to adapt to the social context.
And this realization influenced Cicero.
It did. It led to techniques in Cicero that were adaptive, focusing on understanding and influencing other players rather than being strictly GTO or even purely exploitative in the poker sense. And intriguingly, Noam believes these same adaptive techniques developed for diplomacy could potentially be used to create truly effective exploitative poker AIs in the future.
So the lessons from a complex negotiation game might solve a problem in poker. Fascinating. What does all this imply for the famous AlphaGo paradigm? Self-play driving improvement.
That's a great question. AlphaGo's success path was roughly large-scale pre-training on human games, then powerful test-time compute, search, and finally, massive self-play to reach superhuman levels. It seems tempting to just apply that blueprint to everything, including language models.
The Noam sees challenges there.
Yeah, he points out that Go is a 2-player, zero-sum game. In that specific context, self-play works beautifully because it converges towards a clear minimax equilibrium, which is basically the GTO strategy.
But outside of those neat game types.
Exactly. Outside 2-player zero-sum in multiplayer games like diplomacy or in domains like math or science, the whole idea of self-play becomes like a much more difficult, nuanced question.
Why? What's the problem in, say, math?
Well, in math, what does it mean for an AI to play against itself? It could just end up posing increasingly difficult but ultimately uninteresting problems to itself, like calculate pi to 1 trillion digits or do 30-digit multiplication.
So it's busy work, not actual progress towards meaningful mathematical discovery.
Precisely. The self-play loop doesn't necessarily drive it towards interesting or useful outcomes. The AlphaGo analogy kind of breaks down because the objective function, what constitutes winning or progress, isn't nearly as clear as it is in Go.
That makes sense. This also connects to the idea of world models, right? Does
Yeah.
AI need an explicit internal model of the world?
This is another area where Noam's perspective has apparently shifted. He used to think explicit world models might be crucial. Now, he believes that as models get bigger and more capable through scaling, they implicitly develop a world model anyway, just from learning patterns in the data, so you might not need to explicitly model it as a separate component.
So the capability just emerges from scale.
That's his current thinking. He even suggests that things like theory of mind, the ability to model the beliefs and intentions of other agents, might also implicitly develop in sufficiently large and intelligent models rather than needing to be programmed in. It's another potential example of a complex heuristic approach maybe just going away as the core models get smarter.
Okay, let's broaden out a bit to some other industry insights. Robotics. He has a background there.
He does, a master's in robotics, and he
Yeah.
makes a key point. The research cycle is so much slower and so much more painful when you're dealing with physical hardware.
Yeah, things break, experiments take time.
Exactly. Compared to software AI, where you can run thousands of experiments in parallel in simulation, robotics is just inherently slower. And that's a big reason why software AI seems to be advancing so much faster right now.
What about humanoid robots? Lots of buzz there.
He has a weakly in favor of non-humanoids stance, actually.
Interesting. Why?
He cites the proven value of specialized forms like drones, and he floats the idea that the human shape might just be a local maximum in design space. Maybe the most efficient robot for cleaning your house, for instance, won't look human at all.
Good point. Okay, for us, for you listening and trying to keep up, how do the top labs themselves stay on top of all the research pouring out?
He admits it's really hard. Academic research is still relevant, absolutely. But for a lab like OpenAI, it's not enough to just read a paper. They typically need to reproduce the findings in-house, often at a larger scale, to see if the ideas truly hold up and generalize.
So validation is key.
Validation and scaling. And he also mentioned, perhaps as a slightly sad truth about the current landscape, that social media attention does play a role in which external research actually gets noticed and potentially investigated rather. Visibility matters.
He also talked about environmental limiters on research. What did he mean by that?
He was talking about benchmarks, the standardized tests used to measure AI progress. Many current benchmarks, even really hard ones like the MMLU, Massive Multitask Language Understanding, which some call humanity's last exam, are designed to be incredibly difficult but then are still very easily gradable.
Like multiple choice questions.
Often, yes. Or things with single correct answers. And this focus on easy grading inherently limits the scope of what capabilities can actually be evaluated. Fuzzy tasks, tasks requiring creativity, judgment, or complex reasoning with no single right answer are much harder to measure reliably, even though they might be more valuable indicators of true intelligence.
So the tests we use shape the progress we make.
To some extent, yes. It's easier to optimize for what you can easily measure.
Looking further out, say towards 2030, we've talked about hitting potential walls in pre-training scaling.
Yeah.
Could there be a test time compute wall too?
Yeah.
A limit to how much thinking we can make models do?
That's a really interesting question he pondered. What would cause such a wall?
What did he suggest?
He sees two main factors. First, simple cost. It just gets progressively more expensive in terms of computation to make models think for longer and longer durations, hours, days, weeks.
Okay, economics.
What's the second factor?
Wall clock time. If a model needs, say, 3 weeks to generate a response for a complex problem, then it takes you at least 3 weeks to do those evaluations. Your iteration cycle, your ability to experiment and improve slows down dramatically.
Right, you can't run experiments quickly if each one takes weeks.
Exactly. And he argues this slow iteration cycle due to long thinking times might actually be the strongest case for long timelines for achieving transformative AGI. It could become a fundamental bottleneck.
How might we overcome that?
One possibility he mentioned is developing much better simulators. For example, if you had a perfect simulator of human biology, you could potentially test drug candidates much faster in simulation than waiting for real-world trials, accelerating discovery even if the AI takes time to think.
Interesting. Okay, one more technical term that's apparently floating around OpenAI. Mid-training. What is that? Yeah, he acknowledged the definitions are still a bit fuzzy, even internally perhaps. But generally, mid-training refers to steps that happen between the massive raw pre-training phase and the final post-training phase, which includes things like instruction following and reinforcement learning from human feedback.
Why is it needed?
Because the raw pre-trained models, straight off the supercomputer, are often super difficult to work with. They might seem kind of dumb or unpredictable, so they go through these intermediate mid-training and then post-training steps to essentially tame them, make them more controllable, aligned, and generally useful.
Got it. And just wrapping up with some broader thoughts, he seemed really impressed by Ilya Sutskever's vision.
Incredibly impressed. He highlighted Ilya's early insight way back in maybe 2016, 2017, that strategically, one big experiment is much more valuable than 100 small ones.
Focusing resources.
Focusing resources and having the conviction to make big bets. Noam feels this structural and philosophical difference really helped OpenAI make the kind of hard choices needed to pursue ambitious goals like large-scale modeling and reasoning.
And if Noam could ask OpenAI's current leadership, like CEO Greg Brockman, anything.
He shared the question he'd posed, basically, where does this all go? What does the world actually look like in 5 years and 10 years? What's the range of possible outcomes, good and bad? And, crucially, what could the world or individuals do now to help steer things towards the good outcomes instead of the negative ones? It's about navigating the uncertainty.
A vital question. On a much lighter note, did he recommend any games?
He did. Blood on the Clock Tower.
Oh, yeah. What's that?
It's a social deception game, kind of in the vein of Mafia or Werewolf, but apparently more complex and strategic. He mentioned it's become really popular in the San Francisco tech scene, sometimes even used for recruiting events.
Huh. Okay, good to know. And sticking with games, one last research problem he touched on.
Yeah, related to his game AI work. The Magic the Gathering problem.
How is Magic different from poker or Go?
It involves extremely large amounts of hidden information, vastly more than the few hidden cards in poker, plus complex card interactions and strategic depth. The specific techniques developed for poker, he said, tend to break down when faced with that level of complexity and hidden state.
So how will AI crack Magic?
He believes it won't be through game-specific tricks, but rather that the general reasoning techniques they're developing now, the ones that allow models to think longer, will eventually be powerful enough to lead to superhuman Magic the Gathering AIs. It's a benchmark for that kind of complex partial information reasoning.
Wow, okay, what an incredible deep dive, really, into the cutting edge of AI research. We've gone from, the nuances of game theory and diplomacy in poker, all the way to the grand strategy shaping model development at OpenAI.
Absolutely. We've seen how these subtle shifts in AI capabilities, like the emergence of reasoning, can have these really profound impacts, and how even the leaders in the field, like Noam, are constantly reevaluating their strategies and perspectives based on the latest results.
And if we try to connect all this back to the bigger picture, it seems really clear that AI isn't some static thing. It's evolving incredibly rapidly.
Yeah, from what Noam called his caveman state, maybe towards these potentially complex, intelligent AI civilizations he envisions, driven by both raw technological scaling, the bitter lesson, and also a deeper, more nuanced understanding of intelligence itself.
So what does this all mean for you listening right now? Given this accelerating pace, these shifting paradigms Noam discussed, from the sheer power of scaling, wiping away old approaches, to the move away from harnesses, how might your field or even just your daily life be fundamentally reshaped, not just in the next year, but maybe in the next 5?
Right. And how can we all start preparing for a future where AI isn't just a tool we use, but maybe more like a collaborative partner, potentially helping build entirely new realities?
It's definitely a provocative thought to mull over until our next deep dive.